Hello and good morning, everybody. Thanks for coming, to support the IoT class here. My name is Jericho. Just a little bit about myself. I've always been interested in technology. I love taking things apart to see how they work. And so naturally, this was just a good fit for me. So that way I can take my love of technology and just seeing how things work and trying to make something out of that. So that way I can, also have a new skill and just change industries. I was in the call center industry working in telecommunications for about the last decade. And I just figured after everything that happened, with the pandemic, that it would be time to make a career change to, find some type of happiness in the work that I do. And this is what led me to that path. So today I will be displaying what I came up with here for our capstone idea. So I'm going to go ahead and pull up our PowerPoint now so we can get started here. All right, so what I've developed is a smart scale container system. This is aimed at primarily the inventory systems that are around for any different industry. Sometimes the world can be vastly overcomplicated. So, in this sense, we do sometimes just need something that's simple, solution to a problem that can be easily overlooked. So that's whether you're in a lab that's storing chemicals by weight, in a cannabis industry where everything has to be accounted for down to the gram, or even just the food industry where you have different things that need to be accounted for as well. This is just going to be something that can help expedite that process, just make it secure, efficient, and just more transparent than it ever has been before. So the part list that I have here, we have our particle argon, which is our microcontroller, 2 load cells, which is going to serve as the scale and what takes the weight for our smart container. We have our OLED displays, just giving those weights back. And we have a Hall effect sensor, which is really going to be telling you when the container is open or closed. So that way there's more transparency around who's able to access the different things that could be in these containers. And then just a few other things like a camera, a NeoPixel, and a push button, just to give it some more life and some more function. So the first thing that we're going to be looking at here is a video that's displaying what happens when you have the correct weight. The idea behind this is that you have a parent container that is going to have your main storage of, whatever it is that you're storing by weight. And if something leaves that container and it needs to be transferred to a smaller container, so that way it's movable or accessible to anybody that needs to take that, it would have to measure up. So if you take, let's say 100 grams out of the parent container, you would need to have the child container register that 100 grams has not changed, just to make sure that there's nothing missing in that process. So it's just a way to, be secure around that. So this is going to be the first display. There's 2 examples in this video that show what happens when the weight is transferred correctly and nothing goes missing in between. So right here, we're starting at 200 grams in the parent container. What's happening here is we're taking our start weight with this button to capture what that starting weight is, which is the 200 grams. We take 100 grams out, put it in the child container, and we have a green NeoPixel that displays that that is correct and nothing's gone missing in that transaction. Here is just a second example of the same thing, just to show you that, if something is taken out of that parent container, the same weight is expected in the second container to make sure that nothing's gone missing in between. And here we have that registering again, a green NeoPixel to show that the weight is correct, and that's what the child container is expecting. Here we have a second example of the incorrect weight. So if, for example, there's something that goes missing in this transaction. Here we have 150 grams. If we take the wrong weight and put it in the child container, the NeoPixel turns red to show that something's gone missing in between. So here we start at 250 grams. We're going to take out the amount from the parent container after we capture the start weight. And what's going to happen is it's going to give us an alert saying that the weights don't match up. So in between this transaction, something would have went missing. And this is just an alert for, somebody who would be in management to say, why is there something missing? Why is there a difference in the weight? And that's just to capture that idea there. And this here is just the OLED displaying the different weights in both the child and parent container. And then here is another function where we have the container status. What that means is that when you have your parent container, If it's opened, again, whether it's chemicals, food, or something in the other line of work here, it's just going to say that the container is open. So whoever would be the manager would be aware that somebody's actively, transferring material from the parent container to the child container. So right here, you just have the hall sensor reading to a dashboard that says that the container is open. So when it's open, it shows the red display to show that there's somebody using it actively or it's open. In the reverse, we close it and we get a green example to show that it's closed and everything is secure. Right here is showing that the time is at 7:36 p.m. And basically what this does is I use Zapier, which is basically going to be another way to send another notification or an alert. So when that container is open, whoever's in charge, they're going to get a text message to say that somebody is actively in the parent container, whether, again, they're moving chemicals, food, or whatever it is in those containers to be transferred. Here is just another example of the dashboard where we're displaying the container status, whether it's open or closed. We have the scale weights, which is reading from 2 scales just to give more transparency around that. Same thing with the smart container feed. You're just seeing here pretty much all the activity that's happening, whether there's weight being transferred from one container to the other, just to give more transparency in that process. Some things that I would like to have added with the time constraints that we have. I did have an ESP32 camera module. The idea behind this is that when you get that text message alert, or if those weights don't match up when things are being transferred, it's going to actively take a picture to show just what's going on around that container. So that way there's a way to have accountability around that process if something does go missing in between. Right now it's running independently with its own power source, and it wasn't actually within the code just due to the time constraints. But that's something that I would add to actively be a part of the code and take pictures if there is some type of discrepancy there. These are some code snippets. Right here, the first part that you have is the button. That's where you actually get your weight from the scale, and you have your start weight. And what this is doing is it's calling a function that records the weight. So that way you can, get the alert and show exactly what's happening there. The second one is the function that actually tells you whether the container is open or closed. So with that hall sensor. So that's what that is. Right here, we have our fritzing circuit diagram just to show all of the different the things that we have here, like the load cell, the particle, and how everything works together. Here's our schematic diagram, just so we can see that. Some of the challenges that I had going through this was just being able to capture the weight and compare the 2 weights between the parent container or the scale and the second one. To solve that, I used a attach interrupt to the button. And what that does is it pretty much just captures that start weight for you no matter what the code is doing. So that way you can get an accurate reading and have a starting place. So that way you can compare the weight from the parent scale to the child one. Another instance of another challenge we had is just that whenever I was using the 2 OLED displays, is that when there's 2 of them, they have the same hex address starting off, which was a little bit of an issue. So I had to solder a little transistor or a little resistor on the back to change the address in order to be able to use both of them. When they were both on the same address, there were some conflicts with it displaying the information correctly. So that was a way that I was able to solve that. And this is just my contact information. We have my LinkedIn, GitHub, everything is posted there, as well as my Haxer website, and just my email. So there you have it. That's everything for me.